Alright, welcome to my steam boiler. This video is a little weird, just bear with me I guess. I know I don't make a script for these things and I ramble too much, so I'll try not to do that. But I wanted to make like a follow-up video. I made a video and I'll try to make one of those card things appear on here. My older video, it said, do you need to go beyond the directions or the recommendations of the boiler manufacturers, right? And that's why even though I have a little tiny boiler, I made it with twin supplies. Even though Peerless says you only need one, I made two so that I could turn one of them off and test it, with two and then with one. And in that video, I showed that even just with the one, there was not any sign of any carryover at all. Right now it's making steam. The steam's invisible. Every so often you can see like a little dot of a tiny drop of water show up in this glass here, but then of course it's a drop header, so it's the steam and the water, if there's any water in it, they're going to go through here, then they're going to go up here, then there's another glass where you can see the quality of the steam, and it's really dry, right? There's no drops of water going up there. So I've been messing around with these. I made another video where I put these polyurethane, I think they're polyurethane balls in here, which is kind of fun. You can see the steam pushing the balls around, whatever. So I've got that one turned off for this video. So just in this one, and I was messing around with throttling back this one so that I could get all the steam to go, or most of the steam to go in this side. And I noticed a couple interesting things that I want to talk about in this video. Again, I'll try to keep it short. The first is, so many homeowners, they get kind of screwed by installers because the installers don't follow the recommendations of the manufacturer, right? So they end up, number one, they end up with an oversized boiler, which is a problem in itself. But number two, they end up with an oversized boiler that's not piped correctly. Unlike this boiler that only needs a single 2-inch supply, larger boilers need, like a 2.5-inch supply, or two 2-inch supplies, or two 2.5-inch supplies. It just goes up from there. And a lot of times homeowners don't get that because these contractors who aren't very good, they're only going to be working with 2-inch pipe. They're not going to be putting in 2.5-inch pipe, so they end up with possibly an undersized boiler. And then there's one on Heating Help right now that it's a Dunkirk style boiler, and it's slightly undersized. Okay, instead of a 2.5-inch supply coming off the side of it, it's a 2-inch. So I wanted to make this video to show that yes, that's not great. Okay, I'm here to say you should follow the recommendations of the manufacturer. It's not great to go under, but I want to show you just what this thing can do, even with the only supply really throttled down. So let's begin. The other thing I want to show is over here. I have a sight glass on my return, right? So you can see the condensate coming down the return, and there's no sign of the water line over here because this is a few inches. It's a few inches higher than the water line, which is somewhere down here, right? I want you to note that. So this is normal operation. Everything's fine. Single 2-inch. That's all this boiler calls for. But what if we start to throttle it down? Right now, this is a quarter turn ball valve, right? So when it's at 90 degrees, it's fully turned off. It's not linear, I don't think, because the ball valve isn't linear the way it shuts off, but you all have seen a ball valve. You know how much it's getting shut down. And so let's see what happens. Oh, one more thing. Yeah. All right, I've got here's the current pressure in the boiler. It's 1/2 of an inch of water column. All right, that is like 1/54th of a PSI. All right, because we'll be looking at that later too. So I'm going to crank this down. Let's put it that far. Now, one thing you'll notice, and this is going to be the second part, you're going to notice some condensate shows up here, okay? But it's not boiler water. It's actually condensate, and I want to talk about that later, but I'm pretty sure it's not boiler water because I have 8-way in my boiler, and I think I'd be able to see the color of it. Not 100% certain, but again, we'll talk about this in a little bit. So here, I've got it closed down this much, so you know how much, that much of a ball valve, it's what, 25% closed or 30% closed or something like that. The steam's still coming through. There is a little bit of condensate showing up here, but you know, up here, still totally dry steam. So I've undersized now the pipe that's supplying all the steam to my system by something like, I've cut it by like 30%. And you can see the pressure is about the same here, and still we don't see any water over here, right? We don't expect to see water line here because as I've talked about in yet another video, whatever this pressure is here, it doesn't affect the water line at the far end. But the exception is, because I'm cranking this down, it is going to affect the water line at the far end, okay? And I talked about this in that whole equalizer video. You either believe me or you don't, whatever. I proved it. No one disproved it. That's the way it is. But back to this. So let's see what we can do if we take it like this far. Now this is getting pretty, this is what, 25 degrees closed. This is halfway closed. Now we know it's probably not exactly half closed because of the way ball valve works, right? But it's somewhat close. Go a little bit more. Okay, line up equal here. This is where it is. So again, you just see this, weird condensate pattern happening here, but the steam, my point is the steam's going through, no problem. There's no carryover, there's no surging, nothing weird like that. We can maybe see a little more pressure here, but it's hard to tell because I've got it running now to do a little bit of a setback recovery, so it's eventually then my radiators are going to fill up and this pressure is going to rise. Okay, look, now we can see water here. Now the reason we see water here is not because of the pressure rise here, which is insubstantial, still like only between half an inch and 1 inch of water column. The reason is because I'm throttling it here, right? So when you do this, when you put a valve on your supply, or if you have like too small of a supply pipe here, then yes, the boiler is going to build pressure in the boiler, in the actual boiler, and it will push water backwards out. This is the only time you see this. This is the only time you see the so-called like A dimension having any effect, is when you're throttling down the supply, all right? Does everyone follow that? If not, I don't know what to tell you. So now we're gonna crank it down even farther. I gotta be careful. I'm gonna keep my eye on that return line because as I bump this down, oop, there it went. Okay, I gotta be careful or else I'm gonna be shooting water out my main vent. Where am I at? Okay, right there. Okay, so here at this point, look at how closed that is, right? That's really closed. We're seeing this behavior here with the condensate, but the steam is going. This condensate is like, it's splashing up here, but it's running right back down. It's running right back down the glass. It's not carrying over. I don't think it's even carrying over into the header. It might be a little bit, but there's nothing going up into the mains. The mains are seeing totally dry steam. So I don't know how to determine. I guess I could take one of these valves, get a hold of one of these valves and make it this shut to see how much of an opening it is. But you know how these ball valves work, right? You've seen them. That's pretty throttled. And now if we go over here to my return, you can see the water line has risen 4 more inches or something like that because it's throttled. All right, my cycle guard kicked in. So we got to wait for 60 seconds. I don't know if I have anything to say for 60 seconds. If not, I'll edit the video. But you see this water here. Again, I don't know if it could be boiler water. I don't know. I'm not sure how to tell, but what I've seen is, even when I'm sure it's not boiler water, it still shows up here. And I don't know if it's something with, there's going to be, higher pressure in here, and then once it shoots out, the pressure instantly gets lower. Does that cause the condensate to form? I don't know. I don't know what the answer is. Someone respond in the comments and tell me what the story is with that. But the answer is I don't know. But we can see here that even with this thing throttled way back, so far that it raises the pressure in the boiler compartment by a couple inches of water column, as I showed over there in the return. My point is, what I'm getting to is, don't worry too much if your installer screwed up and made just a 2-inch pipe instead of a 2.5. Maybe worry if he was supposed to make 2 3-inch pipes and he made a single 2-inch pipe, right? That would be horrible. But otherwise, don't worry quite so much. And then see this? This is what I was saying. It's condensate that's forming. It's not splashing up. It's formed here as a result of the steam current that's flowing through here. Like the steam that gets backed up here and gets under higher pressure. And then when it comes up here, it goes faster, the pressure reduces. When the pressure reduces, that shouldn't make condensate form. Is the condensate forming down here and then coming up? I don't get it. What makes this condensate appear here? Here, I'm gonna back this off a little bit. Because see, it's not splashing up. It's coming out of evaporation. It's condensing here. I'm convinced. It's not splashing and getting carried up. These little splashes you see, I believe that's the condensate. When it's running down, it's getting hit, it's bumping into some of the steam that's shooting up past this throttled valve here. I don't know. That's the mystery. That's the mystery part. But the unmystery part is, even with a single 2-inch feed throttled way down, the steam still comes into the system. The system here is at 1/2 to 1 inch of water column. The additional pressure in the boiler we can see here by this is basically a manometer right here. We can see that it went up about this far, so about 8 inches of water column, something like that. That's the higher pressure with this level of shutdown. Now you do have to be careful. If I go any more than this, watch this water level here. If I bump it a little bit more closed, it'll just start shooting up. See, and I don't want that, because like I said, I'll be shooting water out of my main and then up into my radiators. It will not be pretty. So that's what I wanted to show you. And then here's the final surprise, right? The final surprise is I'm running my water line super crazy high. It was even higher than this, of course, before it started making steam. And so the distance between the water line and this level right here is like 20 inches. So just 20 inches of space here. Even with this throttled down, it's not carrying over the water. It's letting the steam go through. That's it. I don't know if this video is worth a damn or not, but there it is.